How do you do, Jan?
Fine. What about you, Michael?
Very good indeed.
You're really a fan of mathematics.
Oh, yes. Yeah,
Sinuses,
absolutely.
cosines, integrals, everything is there.
Yeah. Yeah, I would love to take my favorite Leslie Lamport math paper and turn it into a shirt or a blanket. Maybe I can just wrap around myself and be surrounded by his work.
That Lamport paper, is that the one about clocks, timing
Yes.
clocks?
Yeah.
Okay.
Exactly. Yeah, you know me well. But he's got some good other papers. I mean, his description of Paxos, I thought, was the most approachable that I
didn't
read.
try to read it. That's the one that was not published for 10 years because nobody believed him, or?
Actually, I'm not sure about that. Yeah, I don't know that story. So.
Yeah, he had one paper. Or was that? No, not the one about clocks, I think. About the one about Paxos consensus. He left it for 10 years before he published it.
Mm-hmm.
And even then there was a lot of people who didn't believe it or couldn't prove it because it was so difficult to understand.
Yeah, it is a tough one.
Yeah. If I have a lot of time one day, I will try, but let's first try the normal things.
Yeah.
I made a little bit progress on the model.
Mm-hmm.
So perhaps I can share my screen. But I think it would be useful because, as I told you, I would first like to make a copy of the current application.
Mm-hmm.
So that I have currently in production with my customers. I would like to reproduce that, but based on historical modeling.
Mm-hmm.
And from there onwards, then in iteration to add the features that my customers are asking for a long time, and try to do that by keeping the existing facts, because that's one of the important things for me.
Yeah.
That's where I'm stuck with a current system, that to update every time the data model of the database on the server has to be updated, as well as the data model in the databases locally.
Yes.
And that makes it very difficult to update.
Yes.
And so with historical modeling, we don't have the database on the server that has to be adapted.
Mm-hmm.
We do need to add additional messages, and perhaps we need to convert some messages.
Yes.
I know we perhaps don't fully agree on that one, but I still believe that it should be possible to have on the server or on multiple servers, which are a cluster, the trusted cluster, to have a converter which takes in the old messages as they come in, because customers running the old version of the software, it will still produce old messages. They are converted one way to platform number 2. And so customers with the new version, they will connect only to number 2.
Mm-hmm.
So every time an old version sends a new message, the new versions will receive it in version 2 format. The other way around, it doesn't work. So a customer with an old version, at a certain moment, he will miss messages in the chain, and so causality is lost, and he will get a message: "Look, you are out of time. You have to update."
Yeah.
But at least all the messages that are still, for example, somebody who had no connection, has been working offline, went on holiday, 2 weeks later he comes back and he connects, the data is not lost because it will still be converted as it comes in.
Yeah. Yeah, I think there is a good path forward there, and yeah, exactly the way that you described it. If you envision the immutable runtime as version 2, and then that bridge to version 1, kind of flip that and make that that's now a consumer of the immutable runtime. That's an API integration point, and then apply some of the patterns to integrate that. And if it's one way, then the patterns are pretty simple. It's just detect changes in the static model, in the version 1 model, and convert them into facts. So those patterns are relatively straightforward. The patterns of making it go the other way, now you have to employ outbox, and if you're mixing outbox with ingesting, then things get kind of complicated on that boundary. But yeah, as long as it's this one way, then I think you've got a good path.
I think it should be possible, but we will only know for certain when we try it, and then we will see all the difficulties. One of the difficulties is if we do encryption, because then the server has to upgrade messages which it doesn't understand. But in my case, it will not be a problem, because anyway, I will need to have the private key of the clients on the server, because the clients, they are just working with a mobile phone.
Right.
If the phone gets lost or the phone crashes, that worker in the field still needs to have his data back. So he needs to log in on another phone, and he needs his exactly same private key. So I will have to forward the private keys to the server, which might not be a bad idea in general.
Right.
In your last chapter, where you have servers of third parties, you could have a cluster of trusted servers, and they have the private keys.
Yes.
And then you have the third-party servers, and they don't have it. And even that cluster, for example, 3 servers is just for reliability. If one of the servers goes down, then you still have the 2 others.
Right.
And in case of the upgrading of the messages, you might even run the upgrade program on the 3 servers simultaneously, because there is a message that comes in. The server will see, oh, I already have that message, because the process is one way and deterministic. So as
long as the new message, the fact can be generated entirely from the information. There's no timestamp or random number added, and there's no extra causal information that could be captured. So like a race condition, meaning that you create a fact in one way on one machine versus another way on a different machine, then you can definitely share the load.
So that way we could have a cluster of trusted machines, trusted servers, which all have the private key of the users. And each of them can do the conversion. So even if one is down, then the conversion keeps going on. We will see.
Yeah, and I think that idea of taking the private key, moving it one step beyond the user's personal device is just a reality. That it has to be a part of any solution that has any measure of convenience to it. Being able to move from one phone to another. So some solutions that are completely decentralized in their security model have actually even kind of glommed onto the platform this capability of externalizing your private key. So like a blockchain, their security is completely decentralized. You generate your key pair on this machine, and ideally your private key should never leave this machine. Well, that's not how people actually use blockchain. They have key stores that they trust to keep track of their private key. Because we have seen cases where people have lost control of their private key, and now all this value is in the blockchain, and they can't access it.
I saw in the newspaper this morning an article about a programmer who got, 7,000 bitcoins years ago.
Oh, wow.
When
Okay, yeah.
when
that
the
wasn't a
Bitcoin
big
was
deal.
about
Yeah.
€1, $1.
Mm-hmm.
For just something that he did as a payment.
Mm-hmm.
And he stored them, encrypted them on an external hard disk. And now he cannot find the key anymore.
Mm-hmm.
And in meanwhile, these 7,000 bitcoins,
Yeah.
it's a nice amount of money. So
Indeed.
no,
Yeah.
to avoid that kind of trouble with data, I think it would be best to have it on the server.
Absolutely. Yeah.
What I would like to do, it's a while ago that I wanted to show you the application as it runs today, but I didn't have it. I had a version of my customer on my computer with customers' data, so I couldn't show that. I installed my demo version now, so there is no data in it or almost nothing, but that one I can demonstrate, so that you have an idea. It's a very simple application, nothing special, but then you will have an idea about the model and where I want to go. So, and also for people who are watching on Twitch, they can see it. Oh yeah. That's the main screen. So actually, you see the yellow with where it's written privé. That's private. So the worker can select tasks. So he can either go to private, either he has a list of tasks there. You see, for example, for tomorrow at 12 o'clock, he has to be with that company.
Yes.
Yeah. So if he selects that company tomorrow, for example, he selects that company, and then he can say, okay, I'm gonna drive to it. So if he presses on that little car, then it turns yellow. That means it is selected.
Okay.
So the moment that it turns yellow, the smartphone will register I'm driving, and he will automatically register the timing.
Okay.
Then he comes at his customer, and he say, okay, he selects the meeting desk, and from that time onwards, the software registers he's having a discussion with the customer, and a little bit later he starts working. So this is about customers in agriculture with these heavy machines. So he starts working. Then he has a malfunction of the machine. So he taps that. Then he has to reconfigure the machine, and so on and so on.
Okay.
At a certain moment, he finishes with that customer. Then he goes back to the list. He selects the next one. Yeah, there is only one task now. So he might select the next one, or he say, "Oh, there is no next task. The dispatcher was not there," and he will say, "We maak eigen opdracht." That's Dutch for make your own task. So he can just enter his own task. He has date and time there. He can even give it a name. No, it's not that one. No, I first have to start it. So I drive. The previous one, is it ready? I can say no, because I want to continue tomorrow at that task.
I see.
Or yes, it's completely ready. So I drive to my next customer. I want to give that a name. So I say modify that task. And here we can say customer is, for example, Michael. And the task is historical modeling. I'm not good in typing on these telephones. Historical mod. So, and save it. So that's very simple. It has to be easy because often these workers they are interim workers for that company. So they just download the application on their phone. They have no time for 15 minutes training before they can use it.
Right. Okay.
scroll to the right, then they have an overview of all their tasks which are still in the phone.
Mm-hmm.
But for the moment, there is only the own task. So the whole scheduling from the dispatcher will come on the screen. And if he goes to the other side, so if he scrolls to the right, then he will see all the activities chronological that he did. So you see there on top the reconfiguration of the machine. That was the last one that we did before we went to the new customer. Before that, he has a malfunction. He was working. He had a meeting with the customer. So he can add always some remarks, remark testing. So actually, this version is something very basic, but customers are happy with it. So, but a lot of things have to be added to keep them happy. It's there that I'm stuck a little bit.
Mm-hmm.
So then that data. Wait, I share another screen then. No, I have to say stop streaming, and then because that is connected with what I call the console. So the console is just a Windows application. Okay. So actually, what does it do? First of all, you have all your technicians here. Yeah. So me in blue. I went back in time. So for example, January, which you can see here, January 25th, 2017, 3 years ago. So that day, I just took a flight. I live here in the south of France. So I went to an airport in the north of Spain. I took a flight to Holland. I rented a car there, and then I made a trip to customers. Yeah. So the red, that is normally the customer's place. In my case, it's the official place of my company. There's nothing there. It's just to have an official place, company address in Belgium. And then you can see really where the workers has been. So for example, at 21:43, I was there. 47, I was there. Every 4 minutes, we have a point. Yeah.
Okay. Yeah, so this is just background.
It's a tracking system.
Yeah.
Yeah. So nothing special, but there we need to have a lot of incoming data, GPS coordinates. Now it's every 4 minutes. I want it to be a lot more, but probably process data, because I would like to take a point every 1 second.
Oh,
but
I see.
It's no use to send all that data over 4G.
Right.
Somebody who's driving on an expressway, on a highway, is going straight. So we might have all the data, and then at a certain moment we say, okay, until now he has been. I can interpolate a straight line between all these points with a certain accuracy, and I keep the first and the last point, and all the rest I throw away.
Right.
And I continue so that I have an approximative trip where I have a lot less points. Yeah.
Right, and you can do all that processing on the device and
on the telephone.
Yeah, and only capture the trip itself.
The only moment. So in general, the dispatcher has that map in front of him. And I will say, for example, every 4 minutes, I will process the last data and I will transmit it. But the dispatcher might want to have the data right now. Where is that guy? And in that case, I cannot wait. So I will send the raw data, the last position immediately.
I see. Yeah.
I thought, is he having a snake in the house? But it's not a snake.
No, Biscuit wants some of my attention.
Yeah, she's interested by historical modeling and mathematics. But one, it's a long story for this GPS, but one of the consequences, imagine that the dispatcher say, I want to know the position where he is now. That means that he needs to get the last point. And all the previous points have no importance.
Right.
So in that case, the causality is not important. So I want to send the last point first and present that on the map, and the points behind the previous points, they will follow later.
Right.
So
right.
there is no, with these GPS points, there is no need for causality. I just send the location and the time which I get from the satellite for each point. The next thing are the tasks. Yeah. So you see, there is one here. I'm not sure that you can read it. Is it readable? Or is it too small?
There we go. Yes. It's a little small, but we might.
Right. I will try to make it smaller here.
There we go.
Is that better?
Yes, it is.
Okay. So here you have all the tasks which are current. Yeah. For the moment there is only one. So we see the worker is Jan, the customer is Michael, the schedule date was then, and the task is historical modeling. You have a lot of other data here. Where does he have to be? Remarks, tools that he has to take with him, and so on. So of course he can just edit that very basic functionality. If I say, for example, I want to add a task, I have a little list of customers here. I say, for example, this one, the address is filled in. I can give a remark. I can select one of the technicians here. I can add some machines. Hop, one machine, another machine, and a third machine. I don't know what they are. Doesn't matter. I say.
Unfortunately,
save.
right now the modal that you were just using didn't appear on the screen, but yeah, I can see the form that you just updated.
But you didn't get the.
Yeah. Yeah, I think it's to do with sharing windows versus sharing screens. The modal, it would just considered it to be a different window.
Oh yeah.
But yeah.
Okay. But so you see a second task is available. It says, okay, this task, the status is transmitted to the telephone. A little bit later, the telephone will synchronize, and then the screen will refresh. I will do it manually, and I would say, okay, the telephone of the technician has received that task.
Okay, so you have the metadata of the message transmission and confirmation visible within the application too.
Yeah, that's very important, because otherwise the dispatcher, he thinks that the worker has received everything, and the telephone is no battery or whatever, and the next morning the worker is still sleeping instead of at the customer's place. Here, that's the next screen. We get just an overview. You see, so worker Jan was not available. Wait, how was it? Yeah, until 9, from the 13th of January, 11 in the morning until 7:13 in the evening. Then he went traveling. Then he had some meeting. He worked. He had some trouble with the machine reconfiguration. And then he went to the customer Michael for transport. So just a big overview of all the activities now.
Okay. Yeah, and each one of those corresponds with you pushing one of the buttons while we were looking at the app. Yeah.
That's just in real time following up. The more important things are some reporting that comes out. I will show you one here. That gives you an idea about it. But yeah. Then I have to stop this. It's not easy, this sharing. Zoom has a possibility where you can just take a part of the screen, and that's much more useful. Okay. So then you get a report where it says, okay, on the 12th of February, the technician was with that customer from that time to that time. He was working for so long. He had some reparations to do, repairs for so long, and for the whole day. And then you see the next. The whole day he has been working for so many hours. Overview per customer, overview per technician, that type of things.
Okay. Yeah. So this one, what we're looking at is the detail, but there would be another one that rolls it up.
Actually, very, very easy. So in this way, it works standalone. I have other customers who have connected it. They have a scheduling tool and an invoicing tool. So the tasks come from the scheduling tool directly into the console. And then the hours that they worked go back to the invoicing tool. So that works pretty well. And the advantage is that they can correct the hours over there, because that's currently something that is not in the package. Everything that comes in is not correctable.
Right, yeah.
And that's going to pose some problems with historical modeling. Let's go to the model now. What is important, the supplier is actually my customer. Yeah, so that's the company that has workers and that has his client. Yeah, so he has his clients where he goes and where he performs some tasks. So this supplier, you see my mouse, huh?
Right, yes.
Yeah. So this supplier is my customer. He has his own clients. Wait, let me show you the lookup. So there it goes. Okay. So that are actually the lookup tables. So you have clients, you have workers. Yeah, so that are the technicians in the field. Clients can have, I'm not sure, but that's the right word, a yard address. So a client can have multiple fields.
Okay, right.
And every field has its own address, and they have to go work in that particular field.
Right.
So I call it a yard. I'm not sure whether that's the right, like a shipping yard.
Well, that's your domain knowledge. Yeah, I can't tell you for sure. But
my customers don't care. They want it in Dutch. So if you say, Jan, there is a better word for it in English, tell me, then I can. So, yard address belongs to that client. He can have multiple yard addresses. Then, for that supplier, they have a lot of tools, all this heavy machinery, a bulldozer, all these type of things, but also small tools, laser equipment to see what is straight and so on.
Right.
They also have consumables. Okay. And they also have type of work that are all these activities. I'm working, I'm having a break, I'm repairing something, I have a discussion with my client. Okay.
Okay, so I think seeing both tool and consumable there, a tool is something you want to keep track of. It's that particular machine or that particular laser. Another one that's exactly the same model is still a different entity and independently identified.
A tool has a serial number, and for example, they might have let's say, five trucks. So they have truck number 1, number 2, number 3, number 4, and number 5. And technician 1 might take truck number 3, and technician 5 might take truck number 2. But so you cannot take the same truck by 2 technicians at the same time.
Right. Yes.
So that's something they need to schedule also. They need to keep track of. While consumables might be 2 cube of fertilizer. Or 3,000 liter of one or the other disinfectant for I don't know what, or plastic tubing for water evacuation. Yeah, that is all consumable.
And are they using the system to keep inventory of those consumables? Or is that outside of the system?
No, not my system. But for example, my customers who link it with their main software, in the main software they do an inventory. So actually, the list of machines, I get it from their software automatically.
Oh, okay. So it's got all of the details, like the serial numbers and everything. Technician's not going out there and writing down 17 characters to put it into the mobile phone.
Well, the problem for the moment, I didn't go into that detail, but in the console, the dispatcher application, he has the table, and he can, that was the part that you didn't see. He has just a lookup table where he can say that machine, that machine, that machine.
Okay, gotcha. Yeah.
You have to take everything, all these things with you to the customer. But the technician on his phone, he doesn't have the lookup table for the moment. So he has to type in all these things. So that's one of the things that has to be improved.
Gotcha.
So there
I'm looking
for
sense.
historical modeling. But for example, customers who use it as a standalone system without connecting to another software, they can just import all these lookup tables from a CSV file or from whatever. I just have some regular expressions that I make per customer and that I store in the settings of their software. That's another tab in the software which I didn't show you, but so they can just import it. But so that was an interesting discovery for me, because I was already thinking a long time about these lookup tables. How am I going to implement them in historical modeling? And today, when I was working on this, and last week when I was working on this model, at once I say there is no need for me to make a separate table, because the lookup data is already in the model. Is that correct?
Yes. I would say the lookup table data that you're talking about is actually the natural key of those facts. So you've captured, like for example, the serial number of a tool. If that's the natural key of that fact, that's an immutable identifier for that particular tool. Assuming that you know it ahead of time, you have to know it before you enter that tool into the system. That's the only challenge with using natural keys as identifiers. But yeah, even if there's additional information that you want to keep track of, those I would just say are successors. So
just mutables then.
Right. Exactly.
Yeah. Because in the system as it is now, I keep separate tables where I have all this data. And because these customers, for example, addresses, I might get from their main system an update on the customer address. So if work has been done, then I copy it to the actual work table. Yeah. Because the original, if I just link it and that address is overwritten by a new address, then I don't have the historical data.
Right.
but I think in the historical model, for example, here I have my client. My client is immutable. Then I have my yard address. That one is mutable. I didn't put everything in the diagram because otherwise it gets very confusing. So these are the lookups in yellow. And then let's add the mutables.
Okay.
Yeah, is that still?
Yeah. So there I see a problem in that. So if the
I made even the client mutable because there is some other data that I need to change. But okay, tell me where is the problem?
So so you have the self references at the lookup table itself, at the thing that has identity. So if you for example change a yard address, you change one of the properties of it, this is going to create a brand new fact, and so any tasks that were attached to the previous version are still attached to the previous version. So if you were to say I'm not sure what properties are associated with a yard address that you might change over time. The address you would expect to be pretty static, but zip codes change every once in a while. Just as an example. So sometimes you update an address even though it's the same physical location, let's say. So if that is what happens here, you've allocated some tasks that need to be done at this physical location, and then you just happen to update the address to make sure that things are correct. And now those tasks are no longer associated with that new address. They're still part of the old one. So so what I would say is what you want is for all of the all of the nodes that are currently in yellow, all of those lookup facts, you'll want those to have a successor that has the self-reference that is the mutable property. Like for example,
I see what you mean. In this case, that might be a problem. But often, for example, you make an invoice at a certain moment in time. Yeah, that invoice has the at that point in time current address. A little bit later, the address changes. But if I reprint the invoice 1 year later, I still want to see the historical address, not the new address.
Yeah. So there's I think we've got a way to be explicit about when you want things to move forward and when you want things to stay behind. So so if we were to just kind of walk through this and take the idea of yard address and split it into two facts. So I'll call the first one location and the second one address.
Okay.
So
location is immutable and address is the mutable part then.
Right, exactly. So so I would say that task, I'm assuming that that you create a task whenever the dispatcher says that somebody needs to go to that location, not after the fact. That it's something else further down in the model that happens after the fact. So that task is I need to dispatch a worker to this location, and so that points to location. At the time that you want to capture an invoice, there we can use something like the transaction pattern. Basically, what we're doing is we're capturing. This is an invoice to this client. So the client is an important predecessor, and there you want to capture the history. So there another predecessor can be the address. So now you're saying this was this I invoiced this client for for work that was done at that physical location, at that specific address. And now you've got the history. And so it's kind of a difference between the things that you want to carry forward. So tasks are things that you want to happen in the future. So yeah, it is a historical fact, but it's the need for something to happen in the future versus an invoice is purely something that happened in the past, and now we can draw those specific lines.
No, indeed. So I will adapt that one. So there is a client, he has an address, then the client calls up the dispatcher. Dispatcher will enter a task.
Mm-hmm.
That task has a lot of properties which are mutable.
Mm-hmm.
So therefore I made it mutable. At a certain moment, or perhaps immediately, some schedule information will be added. When that customer says perhaps tomorrow at 12 o'clock somebody has to be here, then it will be added immediately. It might also be added later. That's why I make it a separate fact.
Mm-hmm. Right.
And then the dispatcher will assign that task with schedule information to a worker. Yeah.
Mm-hmm.
So before you can assign it to a worker, it has to be scheduled.
Yeah, that makes sense.
So
other places where we might want to consider having successors in order to keep the identity of a task. So you can update the information about a task, but you haven't actually changed its identity.
Wait, okay.
So a task is like there's an incident, opening a ticket. So that ticket now, that task has identity, and then you can start to add more information to it as a successor, capturing those mutable properties.
To the task.
Yeah.
Okay. For example, remarks or something.
Right.
Yeah, that can be added later to the task.
Right.
Okay.
Yeah, and doing so shouldn't make the schedule info just stuck to a specific point in time, but schedule info should be just attached to that identity of the task.
Mm-hmm. One of these things is, for example, here this take with you item.
Mm-hmm.
Yeah, so the task might be assigned to a worker, and then take with you, for example, a number of tools.
Mm-hmm.
And a number of consumables.
Right.
And I'm not sure what to do here, because for the moment I put it as a take with you fact, which has a link to both tool and consumable,
Mm-hmm.
but both can be 0.
Yeah.
Or is it better that I make take with you tool, which has a link to task and to tool, and then another take with you consumable, which has a link to task and consumable only?
I tend to favor the two-fact approach that you just described there. Yeah, so that you've got you've got more clarity in your model about what the rules are.
Okay, just to keep it simple.
Mm-hmm.
That's the reason. Or okay.
Right. Exactly.
And I will adapt that.
Yeah, and that one might not even need a self-reference. That might be that might just simply have a removed successor. So, for this task, take this tool with you, and so that's kind of added to the list, and then you can remove that tool from the list, but you're not going to go back into that entry and change that to some other tool. For example, you're just going to remove that, add a different tool.
Also, with every take with you fact is just for a single tool or a single consumable then.
Yes, that's what I envisioned you were driving toward, which I think captures what you're after, and so go ahead and use lots of facts. You don't need to make sure that you put the entire list onto a single fact. But then, that way you can just go ahead and manage that list. Just add individual take with you facts and then take them out if you
because that was one of my questions, because later we will come to the delete and restore pattern.
Mm-hmm.
And I was thinking either I can make it one task to one tool or one task to one consumable, and I can just delete this take with you fact.
Mm-hmm.
Either I do it this way and I make it immutable, and I can just add links to it. And to delete it, I make a new fact with no links to tool and no link to consumable.
Mm-hmm. Yeah, and
that's
so
another way of deleting.
Yeah. Yeah. So I favor the first one, where you've got one task, one tool, and one task, one consumable.
Plus delete restore.
Right. Yeah. Plus delete, and in fact, you might not even need restore in that case. And the reason that I favor that is that there's nothing important about the consistent set of tools or the consistent set of consumables. And so if you end up in a conflict situation where you've got multiple take with you leaves in that self-reference tree there, then you'll have this list which contains some tools and that list which contains a different set of tools, and there's going to be an overlap between them, and so now you have to think through what does it mean to merge those two, versus if you're keeping them each as individuals, now there is no conflict that could arise. It's just this this one is in your list or it's
just
not.
The collection of facts is the total.
Yeah.
So it's for easy merging.
Right. Yeah, so only if the collection itself has meaning as a unit would I want to have that be a predecessor list that then you manage that way.
Okay. Yep. And then we do not need to delete if we add, for example, timestamp to it.
Right. Yeah. So if you add a timestamp to take with you in order to make that distinct, then I would say you do want to have the. Yeah, right, exactly. No, you want the delete, but you don't need the restore, because what's the user going to do? They're just going to add that tool to the list again. Yep. And so you get a brand new take with you at a different time. Exactly.
Okay. So then assigned, you can say take with you. There I still have a problem, I realize now. Look, once it is assigned, I have a scene fact. So the scene fact comes from the smartphone.
Mm-hmm.
Once the receive fact. So once the smartphone has received it, the smartphone will add automatically a received fact.
Mm-hmm.
And then the technician, he might have received it but not seen it.
Oh, okay.
So there will be a notification.
Yeah.
And once he has seen it, there will be a seen fact.
Right.
Yeah. So only when it's seen, and then the dispatcher will be sure that the technician is aware of it.
Mm-hmm. Yeah. Yeah, I like that. I like capturing that metadata within the model itself. Yeah, as opposed to trying to somehow build it into the exchange. So this elevates it to an explicit part of the system. Yeah, there is no metadata, there's just data.
But imagine that the dispatcher adds another tool to be taken with you.
Mm-hmm.
So that means that I will have to add a scene flag and a receive flag here as well.
Yeah. Yeah.
And that my final query will be have all the take with you facts and the assign facts for that task and schedule info. Do they all have a scene flag, for example?
Mm-hmm.
Okay. gets a little bit a complicated
Yeah.
query, but it should be okay. And then the next step is once the technician or the worker has got the task, at a certain moment, he will start it. So he will press that button, drive to the customer. At that moment, there will be a session started fact. And when he activates another session, he was driving and then he goes to working, then there will be a session ended and a new session started fact. Because we need to capture the start time, we need to capture the end time.
Yes.
Actually, the start time of the next is the end time of the previous. But it gets very complicated if we only do it that way.
Right. Yeah, we don't need to have that specific causality of I just transitioned from this task to that task. That puts this unnecessary chain within the model. Yeah, kind of like the chess move example. Yeah, that chain was unnecessary, so just kind of flatten it out, and that's what you've done here.
Wait. Because in a later, not now, because it's not in the current software, but in the next phase, we will have to make it possible for the worker to change the hours that he registered. Because often they forget they are having a break, then they start working, they are so enthusiastic, and they forget to push start button.
Yeah.
And after 20 minutes, they say, oh, I forgot it. So the last event, they should be able to correct it. And the dispatcher, he should be able to correct everything. But that's something we will have to add later, because that complicates the things a little bit. But so our session started, we'll have a reference to the assigned. We'll have a reference to tools, to consumables. Or to the take with you, perhaps. No, because it might be the dispatcher say, okay, you take that tool with you, but the worker doesn't use it. So he has it with him, but it has never been used, so it will not be invoiced.
Okay. At the time that you record this fact, you don't know if it's going to be used. So you've started the session and you have these tools. Where I thought you were about to go is that the worker, humans are smarter than machines. So allow the human to supersede the model. Don't make the model too strict that the human can't do their job. And so the worker might know that they need this tool, but it might not be assigned to them. They might not have the take with you, or it might be that tool that's assigned to them isn't there, but another one that's exactly the same kind that would do the job is there. So okay, I'll have to take that one as well. So let them capture the list of tools and consumables that they actually took, even if they weren't specifically assigned to them.
Yeah, that's something which is not in the software now, but it's a good idea to put it in. Because it might be, for example, one of the tools is assigned to them, they want to collect it and they see that it is damaged. So at that moment, they have to take another tool. The dispatcher might not be available instantly, so they just take another one. Okay.
Yep. It might be the right decision, it might be the wrong decision, but it's not our job to determine that. We just capture what happened. Yeah.
Okay. And so tools and consumables. For consumables, for example, they also have to add in how much they used. And the rest of the product will be returned to stock then.
Right.
And then, of course, it's registered the type of work they did. Because that's actually here, the session is just the timing. They say, for example, this tool, I've been using it for so much time, because often these tools are invoiced by time as well.
Mm-hmm.
And the consumables are invoiced by cubic meter, by liter, that type of things.
Okay. So yeah, so there, I would say session started, the arrow going up to those predecessors, you want that to be many, because you might take many tools, many consumables. But now you've captured that. That's information known at that time, so you capture that entire set. So that's the different pattern from what we were talking about with take with you, where you make it singular. So now this really, it is important that set goes as a unit.
Consumable, a star next to it, and
Yeah.
Tool also a star.
Yeah, and then I think you also might want an intermediate, at least in terms in between session started and consumable, in order to capture the units. So yeah, the consumable is
started?
yeah. So the consumable is something that represents a certain chemical or a certain certain material, and so session started has to capture that I took a certain amount of that consumable.
Yeah.
And so that intermediate fact gives you a place to put that amount of the thing.
Yeah, I see. Because now I have nowhere to put it.
Yeah.
Yeah, because I can take multiple consumables.
Mm-hmm.
So I need to, amount of consumable. And I might, tool is a unique thing. So for tools, that's not necessary.
Right.
All right. Then I had a number of questions here. So, wait. Then for delete and restore, the lookups, to keep it a little bit the overview. I didn't actually add the pattern. I just changed the color.
Yeah.
I was thinking, I need for all these facts, I need a delete restore. But okay, take with you, so just the delete. But clients come and go, so delete restore. A yard address, the client might sell a field away, so that address does not belong anymore to that client. A task, I've ended it and the customer cancels, so I have to delete it. Not sure whether I need a restore there.
Yeah, the kind of the rule of thumb that I use is if you could capture any history related to that fact, if it has any successors that are important to you, then you probably do want restore. So we were talking about take with you as not having restore, and that's because it was at the very bottom of the graph. There were no successors. So deleting it doesn't delete any history. There's no history that's no longer available to you. But a task, you definitely would have the possibility of some history there. So yeah, if you cancel a task before you've scheduled it, then no history lost. But now you have to think through in your domain, what does it mean to have canceled the task after it's already scheduled, or maybe even after it's already accepted, and so if the system allows that, and honestly with a distributed system, it's almost impossible to prevent that concurrent
that somebody
operation.
Deletes it and at the same time somebody assigns it. Yeah.
Right. And so advantage of historical modeling that it points out these are not causally related, and so therefore you can delete something and schedule it And so in that case, it's probably best to go ahead and put the restore into the model, so that if something like that does happen, then you've got the opportunity to bring it back and still see all of the history.
Okay. I hadn't thought about that, but it's indeed a very good very good reason.
Yeah.
So schedule info also has to be deleted. The worker has to be deleted, restored. Assigned, the same.
Mm-hmm.
And there is a session. Tools, take with you. Consumables type of work.
Yeah.
GPS, I don't think I have to restore them.
No.
Why I might want to delete them, and that's probably going to be automatically. It has been recorded. Then we do some analysis, and we see that it is a point that is really out of band.
Right.
So that one we just delete.
Yep.
But
that makes sense.
We never have to restore it. The GPS is actually connected to a worker.
Mm-hmm.
It is the position of the phone. And I would want to apply here the period pattern, I think.
Yeah, because that is going to be a lot of data. You don't want it to just accumulate. And so to that end, I might actually recommend moving the period in between. So for a worker and a particular date, now you've got some GPS. That way, if the period is just off to the side, then your query from worker to GPS is still going to return a lot of results. There's no way to filter it unless you move date in between.
I don't follow here, Michael. I don't follow.
So if date were in between worker and GPS, so date is a successor of worker, and then GPS just a successor of date. Then what that means is that you know, from a worker, you can say, I'm only interested in today and yesterday. So now just give me those two dates for that worker. And now do the successor queries, and I see all of the GPS coordinates for those 2 days. Versus the way it is here, you would have to express two predecessors in order to get the limited set of GPSs, which is I still kind of have a hard time articulating why having a query starting with two predecessors is a pattern that I avoid, but it's something that I just kind of over time that became kind of a smell for me.
Because actually, if we start the query from a worker's perspective, then we will have all the GPS data from the moment that he was hired until now. But can we not, for example, say we just, I don't know, because if we start with the date, we will have only today, but for all the workers.
Right.
Yeah. So actually, wait, let me change that one immediately here, just to have a look how it works. Where's my GPS here? GPS goes to date then, and date goes to worker, and not worker.
Yes.
Let's see what that is. Where is it? Yeah.
Yeah. Moved it out, but
and in that way, I will not have a single date fact for a particular day, but I will have for every day. I will have the number of workers day facts.
Right.
Yeah, but
Right.
that
Yeah. Exactly.
doesn't really matter. Yeah. Okay. And that makes actually the query much easier.
Mm-hmm. Yep.
Okay. Let's see what else was there as questions. A client that is.
Yeah, there was just one other thing on the delete pattern is when there is a good domain word to use instead of delete, I would use that domain word. Like for example with task, it might not be delete a task, it might be cancel a task, and so
Okay.
that's capturing something closer to the intent.
Okay. Because the names I gave for the few that I implemented here, what was it? For example, client delete and client undelete.
Mm-hmm.
But I can say cancel task and then uncancel.
Uncancel. Yeah. Uh-huh. I guess you could still use restore in that case. Yeah.
Wait, then
Naming things is hard.
Lookup tables, that was all right. Then okay, one thing I didn't really realize before, but so a client has an identity,
Mm-hmm.
but in this case, so the supplier is my customer.
Mm-hmm.
So this will be a multi-tenant system.
Yes.
But that means that, imagine that a client of the system, so the end client,
Mm-hmm.
is client of multiple suppliers.
Right.
Although it's a fixed client, he will still have multiple instances in the model.
Right.
Because the supplier is part of his identity.
Mm-hmm. Right. And I think that is precisely what you want. And the reason being that the client isn't the entity that's using the system, and so they're not going to expect any consistency out of the system. It's the supplier that's using the system, and the supplier has paid to use the system, and they don't want any other supplier affecting their view of the system. So they don't want to see any tasks that another supplier has allocated for that client. They just want to see theirs.
Absolutely not. Absolutely not.
Yep.
I think that I'm out of business in that case.
Yeah. Yep. So very strictly multi-tenant, and that's precisely what you want. Yeah.
Mm-hmm. Then how to register work? Oh yes, yeah. There we have a problem. So currently, this type of work that can be driving, so transport, that can be pause, repairing, having a break.
Mm-hmm.
But the work can also be in a private mode. And that's very important. So either he's working for the supplier, either he's not working.
Mm-hmm.
And not working, that can be I don't work and I'm not available, or I don't work, but please, if you need somebody for an emergency, call me, I want to earn money additional. Yeah. But both of them are private, and that means that's very important because during his private time, the GPS cannot be activated. Yeah, which is normal.
Right.
What the worker does in his private time is none of the business of the supplier. But right now, so how to say? We have a task. Every task has a limited number of sessions, in fact. Yeah.
Mm-hmm.
A task is made, he goes in work the next day, and so perhaps 100 sessions, and then the task is ended, is finalized, and is invoiced, except for that private task. I've made a task which is private, and every time he says, I start a session, private session, it is linked to that same task. Because I see I still miss something in my model. Task finalized. Yeah, I will have to add that also.
Yep.
Because once it is finalized, it will be invoiced and it disappears from the screen of the worker. But so the private task is never finalized, because that keeps running, and every evening he puts his system in private, and that adds a session here. Session started with type of work privé, private, and the morning when he starts working again, session ended for private, and a new session started for transport, for example.
Okay. So
that means means that we get an endless number of facts.
Right.
And there we have a problem.
Yep,
I think
that could definitely be a problem. So you described a lot of special case behavior for private tasks, and so that's kind of a red flag to me that maybe it shouldn't be the same type at all. That
it's abuse of the model.
Yeah. So I would lean on the fact that you have session started and session ended as the way that you are capturing start and end for sessions versus having a causal chain between sessions. So you don't need to have a literal session for the private time. So I would say you want to just go ahead and have something else in the model that accounts for private time, whether it be scheduled ahead of time, availability, or off the clock, or taking a break. And so let the model for private time be as rich or as simple as it needs to be, but then not overlap that with tasks.
Okay. So we'll have to think about it, because a lot of processing behind it. Because actually, private time or work, it's very much the same. The only difference is that I've assigned it to a task which never ends.
Yeah.
What I could do perhaps is just for private, start a new private task every day.
That would be a compromise. That would at least get rid of the never-ending task. I think it would still be an abuse of the model. And you've got a solution for being able to account for things further down the line. So if your payroll system takes a bunch of records that represent what were you doing during these hours, those records don't have to be sourced from the same kinds of facts. That's just a projection of the model, and so that projection could come from two different places. So I'm going to project all of my my working sessions in there, and I'm going to project all of my private time in there, project them into the same shape and union them together, and now I can give that to the downstream system, and it'll be happy, but I can still keep them independent within this model, and they can follow independent rules.
Okay. We'll have to think about that to come up with something. No, I always felt that it was a little bit abuse of the model, but it in the end you get so used to it.
Yeah.
Let's see how I can solve that. I think wait a sign to.
Yeah,
we had worker. Yeah.
We are about
Then,
out of our time together.
yeah, I'm because you have to go, I think.
Yeah. Office
No.
hours are coming to a close.
I even didn't give you a chance to do the sysop presentation.
Oh no. This is an excellent use of our time, I think. And yeah, I think this is a really great example of here's a real world problem, and here's what historical modeling, just as an analysis tool, can help us to learn about this problem. And then when we get into actual implementation, so we're going to be walking through implementation with Janaga with an immutable runtime, but you could also take this analysis and apply it to the implementation that you currently have. Maybe this is going to shine a light on some part of your existing system where you say, well, okay, I really shouldn't keep track of it this way. If I were to add this other table here, now I could make my current tables a little bit more immutable and capture more information. So maybe it's not a burn everything down and rewrite, but this analysis helps in either case.
I think I'm gonna start from scratch and do it well this time. No, for next week I'm not gonna have a lot of time this week, but I'm gonna try to adapt the model and then start writing out the facts for that and the queries. So actually a little bit of factual language.
Oh, okay, good. Yeah, that'll be good.
And then I will see how far I get with it. But and once we have that, in between I'm still studying a little bit the JavaScript and React and so, and then we should be able to start building something once the model is there.
Yep.
People are making noise. Okay. Michael, thanks a lot.
Yeah, thank you. Yeah, this is exactly what I love doing. I love having these kind of workshop discussions while we're trying to figure something out. So yeah,
I think it's very useful to have your help here, because the things I've noted here, it's really things I haven't been thinking about. And I think if I should do it alone, even with the help of the book, I will still get stuck. But here we have a real, because in making the model, you get, again, questions. I went back to the book, reading again. It's the only way to understand it, to apply it, and to try it out.
Yeah.
Okay, I'm not going to take further your time. Thanks a lot, and see you next week.
Indeed.
Okay, bye-bye.
See you then. Bye.